So hello, welcome back. I am Joel Granados, and I work for Samsung. I'm a Samsung engineer in the global development, global open source team. This presentation was a bit of a merge because we had actually several presentations. So this is why we have 3 presenters here, but I'm going to be the only one presenting. This work is a lot of work from a lot of people, not only in Samsung, but the presentation itself was Adam Manzanares, and also Aaron George had a lot to do with it. So big shout out to them for being part of it. So let's get started. What am I going to talk about? So I'm going to talk about the FTP ecosystem. And it's really nice that Mike did all this presentation before me, because I will not be answering what is FTP. I'll be answering more, how do we use FTP? My perspective will be from the host side. And so all these internals that Mike was talking about, I will not touch on them. I will more see what it is that we need to do from the host side. So I have separated the presentation in 2. I will talk about high-level libraries, specifically Cachelib and RocksDB, and the work that we've been doing with these libraries. And then after describing those 2, I'll go through several supporting projects that are necessary to work with FTP in the ecosystem. So for the libraries, I'll go a little bit more into detail. I'll try to say what is the motivation to go with FTP, and also try to give a little bit of results, like some numbers, very, very high-level numbers. With the supporting projects, I won't do that. I'll just describe what it entailed to onboard FTP into the projects and what the motivation of FTP in each one of them is. So let's begin with the libraries. And we begin with Cachelib. So I'm going to answer what is Cachelib, what is the motivation, how did we onboard FTP, and I'll give some numbers. So Cachelib is a local cache. And it has kind of 2 components. It goes and uses DRAM, and it can also use SSD as the cache place where it puts the cache. So for the DRAM, we don't really care much about it. We're going to focus in the SSD cache, the code name Navy. I like that name. So they basically separate the cache into 2 engines. There's the large item engine, and then there's the small item engine. And the large item engine is basically items that are 1K to 16 megabytes. And it's very nice because it writes sequentially. So we like that. SSDs like that. And we can probably expect a write amplification of 1 or around. On the other hand, small items are less than 1 kilobyte, and they are written randomly. So it's a bit more, not so good for SSDs. And the IO pattern is probably something that will give you a write amplification that is not 1, that is a bit higher. So it's good to notice that on the implementation, they do the separation, but it's also separated on the LBA space. So they basically take the device, all the LBA space, and they separate it into large items and then small items. And yeah, that's what, in a bird's eye view, the part of Cachelib that we care about. So what's the problem? The problem is that large items and small items go together in no particular order into the device. And then you have a mix of valid blocks and invalid blocks, much like you see in the figure here where it says no FTP. So that's not good. That's not good, because then when garbage collection wants to create a valid block to write again, then it has to do a lot of work. That will create WAF, and probably you'll suffer on quality of service as well. So we bring FTP, and what are our expectations when we bring FTP in? So we expect the 2 types to be segregated, and the figure looks more like the one that is on the bottom that says FTP. And the invalid blocks are more organized. And in being so, then you facilitate the job of the garbage collection, which in turn gives you better write amplification and hopefully better quality of service. Or at least that is our expectation. Sure. This one. Yes, RUs. Yes, that's what that means. Sorry, it's supposed to be R, capital U, S. Exactly. So what did we do to onboard, or what did we have to do in this particular case to onboard FTP into Cachelib? So we went and added the path that Cachelib takes to the SSD. We went through IO_uring command, go through the raw character abstraction to the NVMe and down to the device. And the path selected is just you use the IO_uring command interface through the kernel. So our expectation is we take these two types of items and we segregate it with the hint or the placement identifier. And so what we had to add to Cachelib in order to do the segregation is to, on the right, whenever it wants to write the cache to the SSD, we kind of piggyback a hint into that write command. So we had to change the interface. This means adding the placement identifier. When it says PID, it's placement identifier to the write functions. And also, Cachelib did not have IO_uring infrastructure to begin with, so we had to add that to the code. So the path actually works through the kernel. This was basically added. The path is a completely different file, and then the hints were added in a new device type, which is an FDP device type. Okay, and now we see after implementing it, we did some tests. We ran some tests, and so blue is non-FDP, and red is FDP. And here you see two figures, and you're looking at the write amplification. The top one is 80% utilization, and the bottom one is 70% utilization. And here, I only describe the write amplification, but we also have numbers for throughput. It was a bit too busy, so I didn't put the numbers here, but if you are curious, just come look for me and I can share the numbers of both these figures for both non-FDP and FDP on Cachelib. So what we see here is what we expected, which was without FDP, the write amplification goes up as you start to utilize the device. And when you turn it on, then you see more or less 1. I believe it's not exactly 1, it's a little bit 1, but I mean, in comparison, it's 1. So, and we see this even though we up the utilization to 80%, which is very nice. It's how full the device is. So you run, you can, I think one of the, this is by the way, work from Arun. So when I spoke to Arun George, he said that you can configure Cachelib to say, okay, can you please utilize just 70% of the device? And it'll stop at a certain point, and it'll just maintain that utilization. So that's what I mean. And the question was, what does utilization mean? So with this work, we are running a PR to upstream this, and you can see the link over there. So if you're curious about what that PR entails and what's going on, you can go to the link and see the discussions. It's ongoing. Yes? That is a very good question. That is an excellent question, and this is part of the future work. So that's one of the we have, of course, several hypotheses, but we need to experiment a little bit more. And I think one of the things that Arun wanted to do moving forward was to exactly characterize what it is where that write amplification went for the small items, because it's in some sense it might be that you need to wait a little bit more, and then the write amplification for the FTP will go up or not, or you need to change the experiment a bit. So that's, we need to explore that a bit more. But, and the question was, where did the write amplification for the small items go? Yeah, and then actually to add to that future work, we can do a little bit more exploration on the WAF. We can also segregate, because right now we're just segregating small items and large items, but I think there's an opportunity in the large item engine to segregate even more. And maybe we can get a little bit more WAF out of it, or maybe change the performance. And also, Arun was talking about that maybe it would make sense to generalize this into some sort of FTP library, but I mean, those are like future considerations, and I mean, right now, the push is to get the PR into Cachelib and take it from there. So that was Cachelib. Now we are going into RocksDB, and it's going to be the same. What is it? What's the motivation for FTP? And what did we do to onboard FTP into RocksDB? So as many of you know, this is a key value store, and it's a log structured database. In a sense, the input comes from the user. Every write or every put goes into a mem table that's on memory. This gets kind of cached in memory. And once this gets to a certain size, then it gets flushed to persistent media. It gets flushed to a leveled kind of SS tables. What is this SS tables again? Sorted string tables. And then the thing to notice here is that different levels of the SS tables, they have different time to live. And as you move down, you increase the time to live. So yeah, that's more or less what that is. And what's the motivation? It's exactly the same as with Cachelib. I think we can, I basically did a copy paste of the slide, because it's when the different time to lives go down, they mix. That is not nice for garbage collection. We have increased WAF. We don't want that. And it probably is not good for quality of service either. And we want to change that. And the expectation of adding this, onboarding FTP would be to avoid the write amplification. And it's the same as in Cachelib. We segregate the levels, then it's easier to reclaim the unused or invalid blocks, because they have been invalidated already by the host, because everybody is segregated into their own little blocks that, you know, become invalid all at the same time. Or that's the idea. That's the expectation. Okay, so what did we do to onboard FTP into RocksDB? We took a different path down to the device, and when you compare it to the work that was done on Cachelib, I think this one is a bit easier, because we took xNVMe, and then xNVMe takes us down through IO command that takes us down through the NVMe driver to the actual drive. And I think it's a bit easier because xNVMe takes care of all that, like, interaction with IO, and we don't have to care about, you know, setting the IO interface, and no, you just call a command in xNVMe and it'll take care of it. I think it's nice. And so we used RocksDB. RocksDB has a very nice plug-in interface, so we used that to create a new environment to, you know, implement all this. We were very careful at whenever RocksDB removed or deleted an SS table to deallocate that SS table, to send down the message to the drive saying, by the way, this LBA range is no longer needed. And RocksDB, again, very nice of it to have the write lifetime hint. And that was already in RocksDB. We didn't have to do anything. We just took those numbers and we related them to a certain placement identifier. So there's not set or none, and that one is the placement identifier 0. And then you have short, medium, long, extreme, and then we fill out with the rest. And these are the hints. These are the FTP hints. So basically for RocksDB, instead of 2 hints that we use 5. And we send that down to the drive. Yeah.
So when you're sending these hints down, are you just unconditionally putting them in and either the drive can interpret them correctly or not?
So the question is, do I put the ID unconditionally and not care about what the drive does? Is that the question?
What the drive is configured for? Is there a piece where you're actually finding out the configuration of the drive?
Yes. So I'll talk about this a little bit later, but just to give you a hint of what happens. Of course, this is RocksDB, and then the application or the library or database runs at a certain configuration. But I have previously configured the FTP drive and said, okay, I need 6 or maybe a little bit more, but at least, I need 5. And then I use those 5. So that there has been a configuration step before.
What does the RocksDB do then? Does it find out what that is, or does it assume that it's already there?
So the question is, what does RocksDB do? Does it find out what it is, or is it already there, right? And or assume it's already there. So the part of onboarding FTP is precisely that. So RocksDB itself, without the added code that we added, it doesn't know. But what we did was we know what placement identifiers we have available, and then we related that write lifetime hint. That one is RocksDB, and we related it to one of the ones that we have, one of the placement identifiers that we have.
I think you're missing the question.
Oh, sorry.
My question is did you modify the code? Did you hard code ID 0, ID 1, ID 2? And if you go and run this on another drive, you'll be sending
I see.
the same IDs, and then the drive you hope will either do them correctly or ignore them.
Yeah. So the question is, did we hard code the IDs? And the answer is, in this case, yes, we did. But it doesn't need to be this way. Like, as I was gonna comment a little bit more on the next slide, this isn't as official as Cachelib, because this is a test bed that we use internally. So we don't have to be careful with these kinds of situations, but I can easily see a way that you can maybe implement a configuration file where you say, look, by the way, these are the IDs that I'm using for short, medium, long, extreme, for this particular RocksDB.
So with Cachelib, you actually put up a pull request. Did you fetch the configuration, make sure that it's what you were expecting before you?
With Cachelib, it's a bit easier because there's only 2. Yeah, so.
Still, the question is, did you read it, or are you sticking them in hard-coded?
I think it's hard-coded also in Cachelib. Okay. And I mean, it's a process, right? It's a PR, so maybe they change that, maybe they don't. It depends on the process, right? So yeah, good question, thanks. Yes?
So is the RocksDB plugin API still file-based?
Yeah, that's actually an excellent question. So yes, it still is file-based. And yeah, okay, so here this square that says xNVMe, it's a bigger square than what it appears there, because in the plugin, so the plugin itself uses xNVMe, but the plugin itself kind of has a way to translate that file-based idea that RocksDB has into the drive, because we use a direct IO. So there's no, you jumped VFS and you jump the block layer and you go directly to the drive. So there needs to be, in the plugin, there needs to be this kind of like translation between, yes, by the way, you expect a file. I will translate that into LBA range.
And you store that somewhere on disk so that later when it says, I want to read that file.
Yes, exactly. Yeah. And so, sorry, I don't know if I repeated the question. The question was, what do you do because RocksDB expects files? How do you implement that and it going down when you basically skip the VFS layer in the kernel? Cool. Very nice questions. So at the end, yeah, we have with the status. So we have a bit of numbers, and again, blue is no FTP, red is FTP. And in this figure, I kind of, since it's percentages, I put two types of information in the same figure. So the one that is over 1 is the write amplification, and the one that is below 1 is the utilization. And I ran this with dbbench, the benchmarking tool of RocksDB. And initially it was just sequentially filled, and then I randomly overwrote twice the more or less the size of, well, not more or less, like twice. The first overwrite was 60% around, and then the second overwrite was 80% or around. And then we see that with FTP, we get the expectation that the write amplification is maintained around 1, and without it, it grows. And I think it looks like it keeps growing. So the work that we did here, as I mentioned before, is not something that we want to PR, or it's not something that we want to upstream. It's a very good POC because it shows that it is possible, and you get the nice results. And if at some point somebody wants to do something with it, it's open source, and anybody can take a look at what we did. Additionally, it's one way of doing it. Because if I were to, since this is a test bed that tests data placement, it's not necessarily FTP specific. So if I were to do it again, maybe I would do it a little bit differently. So yeah, it's up for grabs, and yes?
In some of the proof of concepts that led up to FTP, they found that there was a certain amount of work that was going to be really flat, the number of flights were going to be really random, and you couldn't place them very well. Does RocksDB have a certain number of flights or some percentage?
Like random writes? Like random writes?
Yeah, that behave random, but the majority can be.
Yeah. So the question is, does RocksDB have a certain number of random writes that maybe fiddle around with the WAF value? Is that correct? Yeah. So yes, that is correct. RocksDB mainly puts everything in the SS tables, and these are the big files. Those are in sequentially, and I think WAF in that case does not suffer because it's sequential. However, they do have little like temporary files, but they're so small compared to the other writes. So I think if it affects it at all, it's not so much like you don't feel it in the write amplification. And additionally, with FTP, you can just say, okay, just go with these types of writes that are random. Go into, you can either have another placement identifier, or you just stick them in the default. Yeah. Yeah. Oh, sorry. Again. Yeah.
Carbon footprint possible. Question was around, was this drive capable of or configured for persistent versus initial isolation?
Yeah, you're referring to the FTP isolation. Yeah. So this was not persistent. And that's an excellent question, by the way. So the question is, what about persistent versus, what's the name of the other one? Initialized isolation. So yeah, no, it wasn't. It was only initial, which I think my hypothesis is, right, because I haven't tested this, it would be better with persistent on the long run. On the long run. No, but the thing is that if you continue, like it goes until 97, right, times 10 minutes, whatever that is in hours. But if you go and say you run this for weeks, years, maybe then you'll get this difference between persistent and non-persistent, because then you get the garbage collection, which doesn't have to do a lot of work to begin with, but some of it, and then you get it's not mixing with persistent isolation. So yeah. That's a fantastic question. Yeah, yeah. Sorry. So this is 97 times 10 minutes, times 10 minutes. And so the drive was preconditioned once, and it was filled up to whatever the full capacity it had. Sorry. And then you have an initial sequential write to 60%, and then you have an overwrite of that 60% until it overwrote the exact amount of data that it initially wrote on the sequential, and then you repeat that again. So I think you would kind of rewrite it, I don't know, 3 times, a little bit less, because you don't fill it to capacity ever. It's reading. Since RocksDB writes the SS table, then does the compaction, and then it basically deletes while it's writing. So yeah, approx. Yeah, cool. So yeah, so those were the numbers of RocksDB, and yeah. Yeah.
So the write lifetime hints were introduced to RocksDB for free.
Mm-hmm.
Did you go back and compare the results that were like 10% back when they
For streams. So the question is, did I go back and compare the results for the lifetime hints that were introduced in RocksDB for streams? The answer is no, I did not. My interest was more like, okay, FDP versus non-FDP. But yeah, that would be interesting to see, I don't know, maybe we have a better WAF in FDP or a better WAF in streams, and what that entails. That's a good feedback. Thanks. Yeah. So now let's see how much time I have. Okay. The supporting projects. So the idea with this talk is to see the ecosystem. So right now we went on the higher levels, and now what I'm going to try to do is I'm going to try to list basically. There's nothing new about what I'm going to say. It's just this is what exists. This is what is there. This is what you can go use right now in order to use and write with FTP. So I'm gonna go and talk about FIO, nvme-cli, QEMU, xNVMe, and IO Passthru. And I'm gonna start with FIO. So FIO, I think everybody knows what FIO does. FIO is fantastic, I think, because you can choose so many paths to get to the device. And I think that's one of the nice things that you might want to do if you are undecided to see where to go with FTP. So you can say, which path do I want to go and take to the device with my FTP implementation. It's a very nice way to do a little hello world kind of thing, where you do a job, you configure it very, very simple, and you poke your device or your QEMU and see if everything is working as it's supposed to. It clarifies hypotheses in the sense that maybe you want to make sure that the random writes are different than the sequential writes for FTP, and then compare them with non-FTP. And yeah, it's really nice to test performance, and this ties with what I just said about hypothesis. And and you can test different paths. So what's the relationship between FTP and FIO? So what was done to FIO to onboard FTP? And so, as we heard in the previous talk, there was, you have to kind of ask the device and say, what are your placement identifiers? How many do you have? What are my options here? So this is one of the things that was added to FIO, and it internally knows how many placement identifiers it can have, because not all the devices have the same amount. Also, with FTP, you need to attach the hint, the placement identifier, to the right. So in FIO, that was also added. So it can, with the configuration, it can just piggyback the hint on the right. And I think that's going to be true for the totality of my list. This is something that needs to be added in order to make FTP work. So you can FIO works in configuration. Yeah, sorry.
Sorry, just to clarify, the placement ID is defined per job. You cannot define per IO.
Yes, in FIO. In the next slide, I think I'll talk a little bit more about that. If you have the same question after the next slide, please ask it again. So you can assign the placement identifiers to the job, and it can be one or it can be several. And you can also control the selection. It's because when you assign a list of placement identifiers to a job, you cycle through them. So on every write, on every block write, you use one placement identifier, and then on the next write, you use the other one, and so on and so forth. And you can do that in a round-robin way or in a random way. Yeah? Does that answer your question more or less?
I wanted just to remark that you should look at the recent changes we did with the command variety, where you can fully deterministically control per IO your priority to assign to IO.
Yeah. Yeah.
So you could reuse the same.
Yeah, definitely.
Same code.
Yeah.
More deterministically control the
Yeah. Yeah.
You can then run with a single job, which is way better.
Yeah, thanks for that. And to add to that, I think all this is old news. This is something that was added to FIO November 2022. So one of the things that, as you said, we should do is maybe see where else we can change things to make things a bit faster, better, more options, and so on and so forth.
I agree with the IO look at the CD file something function.
Yeah. Okay, thanks a lot. So getting back to the old way of doing it, so in FIO, you have these job configuration files, and it's very easy to add FTP. You just need at least two options. And the first option is FTP equals 1, that activates everything in the sense of it'll use the placement identifiers, it'll go and see how many placement identifiers the drive has, and so on and so forth. And you can define how many placement identifiers you use per job. So in this case, for example, you have a write-heavy job. It's random write, it'll read and write, and it'll write until 30%, and it's time-based, whatever. And additionally, it has 4 placement identifiers. And this in FIO, these are not the placement identifier IDs. These are just the offsets. So what it's telling you there, I'm going to use the first one I find, the second one I find, the third one I find, and the fourth one I find. And then additionally, I don't have it in the example here, but you can also select the way you cycle through it. I'm sorry?
What is placement type? PLI type?
The PLI type, where are you? The PLI type, sorry, yes. So the question is, what is the type in FTP PLI select? Yes? The type is either random or round robin. And so for when FIO does the write, and you select here, for example, you have 4, on the first write, it'll write with 0. On the second one, it'll write with 1, 2, and 3 if you have round robin. And if you have random, it'll just select them randomly. And that's that. So nvme-cli, and I think also a lot of people here might know what nvme-cli is. We wanted to extend the functionality of nvme-cli because you have to have a way to enable FTP. And one of the ways that you can do it is through a command line interface. And that functionality fits very well with what nvme-cli already does. So it was kind of like a no-brainer to add FTP to nvme-cli. Also, it has a lot of tooling in nvme-cli, and you can do very trivial tests and say, hey, by the way, can you please write, 3 bytes and see what happens with FTP. and actually make sure that it's alive and that the FTP hint actually makes its way down, and so on and so forth. But I think enablement is the forte, or at least the one that I use the most with nvme-cli. And one of the things that you need to do is, for example, to ask for the configurations. If you remember what Mike was talking about, could be several configurations, there's at least one. But if there's several, you need to say, okay, tell me what configurations do you have? What do these configurations mean? It'll basically list the information, the FTP information. And then you can select what configuration it is that you want to use. Yeah. So what was done in nvme-cli to onboard FTP? nvme-cli, now I realize that I don't have the actual argument names, but please approach me. I can give a bit more information about the names of each argument. But again, remembering more or less what Mike had to say, or what the previous talk had to say, there are FTP helpers in terms of statistics, events, configuration, reclaim unit, handle usage. So nvme-cli added all this in such a way that you can access this in the command line. There's additional helpers like FTP status, FTP update, and set events. The status is the relationship between the reclaim unit handle and the namespace. The update is a way to reset the reclaim unit. So if you want to, if the reclaim unit is half written, you can say, please reset it, and then you'll get a new one that is not written at all. And the set events enables and disables the FTP events for the device. Again, no, one of the important additions is management sent receive, and this will be true, I think, for all, where you can query, for example, how much time the RU is valid for and how many available writes I have. And you can reset the RU to give you a new one without any writes in it. So that had to be also added to nvme-cli. This is all upstream, again, I guess old news, right? But it's been available in v2.3. And I have a little example of what I did to activate FTP on my devices. And this ties very well to, I think, the third or fourth slide in the previous talk, where the spec really defines what you need to do to enable FTP. And so you first validate that the device is capable on the first one. Then the second one is you delete all the namespaces because you can't have any namespace in there if you want to enable FTP. Then you print the configurations that are available, select one. In this case, there's just one configuration. I selected configuration 0. You set that configuration and you set FTP with that configuration, and then you ask it again, is FTP configured, to make sure that the configuration has gone through. Then you create a namespace. And things that are, can you see my cursor? No. The thing to notice is the ncap, sorry, the -p. Those are the placement identifiers that are available in that namespace. And the .n needs to match that. Yeah, and then the rest is as it was with non-FTP in nvme-cli. So you have a namespace, then you attach it to your controller, and you're done. That's it. It's yeah. Okie dokie. So we continue with QEMU, and again, I think all of us kind of know what QEMU is. Emulate, and I think it's obvious the motivation is to emulate an FTP device without actually having an FTP device. You don't have to go and buy, okay, thanks. You don't have to go and buy a device to do your testing. So that's I think the main motivation. I also used it in other nice ways, which was to actually debug what I was doing. So QEMU has tracing functionalities, and it's really nice to actually see the FTP trace appear when you send the FTP down. And if you don't see it appear, then something is wrong, and then you can do something about it. I also used it in a bit of a tricky way, which was I executed the debugger on QEMU and actually went through where it received the FTP message or command, and it made me a bit more sure of what was going on when I actually did something in RocksDB or Cachelib or whatever. So you can use it in different ways. But the main one, I think, is emulation. I also put this get inspired by QEMU implementation because sometimes you have a doubt of what should the header exactly have or what's the offset or something, and then you can go and peek into QEMU's implementation to find that out. The onboarding has a lot to do with what we've already been talking about: FTP logs, configuration, RUH usage, stats, events. I was super surprised that it didn't have directives, so they had to add directives to QEMU. And as I also mentioned before, IO management send receive. The implementation in QEMU is not persistent. Okay, so maybe I talk about it here better. There's a list of what is not there. So this is available in version 8 of QEMU. And I have a little example here of how you can use it. You need to attach it to a subsystem, and then you just need to say, yes, I want FTP, so FTP true. These are the number of reclaim unit handles. This is the number of reclaim groups, and this is the size of my reclaim unit size. And that's it. But you don't, in this type of interactions, you don't need to do enablement. So, for example, in QEMU's case, they didn't do this. There's no sense in doing it. Once you boot the guest, it'll just boot with FTP on. It's not persistent, so once you turn off the guest, it'll all go away. And there are things like timers, like how long an RU is valid for, or how long do you have to write it, and that's also not in the implementation or in the onboarding. So finally, I'll talk about xNVMe and IO-Uring. xNVMe is a library for NVMe. It's really nice because it provides a lot of paths down to the device, and if you remember from the RocksDB, was used in the RocksDB implementation. Same story, IO management, send receive, statistics, events, configuration. There's extensive testing on xNVMe in the sense that xNVMe also has tooling like nvme-cli. And so the testing for FTP goes through the tooling of xNVMe. And so there's a lot of that went into the onboarding of FTP into xNVMe. It's old news. It's been available since version 7. I think June 16, I don't know what year it is, but it's not to 23. I think it's 22. I have to change the slide. That's xNVMe. IO Passthru, it's something also that has been available for a very long time. IO Passthru allowed us to use the kernel without using the kernel. Like, we avoided the VFS. What I mean is, like, we avoided the virtual file system and the block layer and just went directly to the NVMe driver. And we use things that are available since version 5.3, car device, 5.19, IO-Uring command. So I think the message here is we didn't really have to do anything in the kernel. And if you have a kernel that is over 5.19, then you're good. So no worries. So again, we talked about libraries, Cachelib, RocksDB. We gave some numbers. We talked about supporting projects, FIO, nvme-cli, QEMU, xNVMe, IO Passthru. We gave a bit of an idea of how to use things in the supporting projects, and we gave an idea of how to, what entailed the onboarding of FTP on all of these projects and libraries. Thank you for being here, and questions. I see a hand up.
Yes, any plan to support file system interface in the kernel?
Yeah. Very good question.
Files, which would make total sense, and
Yeah.
work
Yeah, total excellent question. So the question is there any plans, are there any plans to put this into the VFS and file system infrastructure of the kernel, right?
Well,
Yeah, yeah.
You can actually pass that down to file system.
Yeah. Very, very good. Very careful with words. Yes. So I think for now we would need to see who needs it. If for example, for Cachelib, it wasn't necessary, and if somebody pushes for it in terms of clients, we need to see if the ecosystem can handle it or wants it. So yeah, I think you know more than me if.
Long approach. I mean, if you're in the middle of file system, any application you can take out the data super easily.
For sure.
That's a lot less work in the ecosystem.
For sure. For sure. For sure.
In there. So one problem that we've seen previously, right, is that we don't want to push completely all the way, right? This is some sort of blueprint. And the end user, whoever's interested in it, and whether it's another vendor or who else it is, like bringing someone else into the ecosystem to do the file system work, we're going to support and help through, but we don't want to just push everything on our own, basically, right? And so we're looking for more people to get involved in the ecosystem
Yeah.
and do that last push on, say, the file system.
Yeah. Yeah, it would make things easier, I think, to move forward. Yes.
How would you do the right hints in the file system?
Sorry.
How would you do the right hints in the file system?
I think there was a streams implementation. No.
Support streams.
Yeah.
That was killed.
Yeah, it was killed. Exactly.
And kind of reintroduce it instead of stream ID,
Voila.
specifying for your file.
Yeah. Yeah. So the answer is it has already been implemented, right? But yeah, it was taken out.
Priorities, the command priorities, like somebody
You
says,
just put the marquee hits, you could use that.
yeah, I thought that can be used through the file system and things like that, yeah. So that's another way of getting it. But yeah, some of the plumbing is missing now because of some changes, but yeah, we'll work on that with others as well.
Yeah. Any more questions? Yep.
For Kachelib, did you have to change when and how you deallocate data?
So the question is, for Cachelib, did I have to change when I deallocated data? So the answer is no. You have to keep track of the LBAs, but SS tables are SS tables. You get from LBA, and then you basically know.
Cachelib.
In Cachelib, sorry.
Cachelib sends trim. Cachelib is already trim already.
Yeah.
So it already uses trim within Cachelib, and so that could be one mechanism to tell the drive you're not using it for something anymore.
Yeah.
So that's one way of deallocating data from the project, usually trim from it.
Yeah, exactly. Sorry, I misunderstood. Yes.
You mentioned that QEMU supported FTP statistics. Does that mean with QEMU I can forecast right now?
I think it doesn't support full statistics, but I have to get back to you on that because I don't exactly know if that is possible. I think maybe Klaus might know the answer to that question, but yeah, we can get back to you on that. The question was, does QEMU FTP implementation support statistics, and can you get out yes?
Can I measure right now with QEMU?
So QEMU and underlying so you can measure basically external so you can see how many writes actually went down among storage QEMU, and then you can sort of compare that to how many writes go through your
Yeah, exactly. And so maybe for the microphone, the answer was it doesn't have an FTL, so the write amplification, the device write amplification, because that's what we're talking about, is not something that QEMU does. Any more questions? Awesome. Thanks a lot.